Ahora sí. Empezamos a grabar. Share screen. This one. Okay. You have this problem from the release test. Dice, an object moves along the x-axis with initial position x of 2. The velocity of the object at time is given by v. I don't remember if we did this before.
Creo que
I guess we did this one. So let's do the next one. Let's do this one. Right here. This is a particle moves along the x-axis so that its velocity v at time t for 0 less than t less than 16 is given by vt equals e to the 2 sine t minus 1. At time t equals 0, the particle is at the origin. A, first question. One of the axes, on the axis provided, sketch the graph of vt. It's okay. Well, this is going to be a calculator allowed problem, correct? So, let me just open the calculator. Where is it? Ah, es this one. Aquí está. So vamos a abrir la calculadora. Let's open the calculator. And let me see. There it is. Here
También está comiendo frijoles.
Está bien. ¿Frijoles charros?
Sí.
Ah, está bueno.
No hay otra manera.
Me gusta. Ok. Bueno. Resume share. ¿Sí ven la pantalla? ¿Ven esta? ¿Ven la calculadora?
No, es que lo tienen en window.
Ok, bueno, entonces stop share. Déjame poner otra vez. No ha llegado nadie más. No ha llegado nadie más. Déjenme hacerle stop share. ¿Ahora sí?
Sí.
You see the screen now?
Sí.
Okay. With a calculator, it's very simple because the only you have to do is graficar, graph the equation you receive, right? And sketch it. So my equation is going to be E, no, we have to do E to the 2 times 3 sine x, and then minus 1, right? And we see this, let me just take this one. You see the behavior of the function. Obviously, we're not going to take the negative. It's beginning here. So podemos hacer esto. So we move the screen, and then we see the behavior of the movement. Remember, this is the position, right? This, no, so that is velocity. This is the velocity. So the velocity is positive all this time, reach a maximum. So the velocity increases till this point, right? Then decreases, becomes 0, positive, and then becomes negative. Reach this minimum, becomes negative, negative, less negative, then 0, and then positive. So this behavior is something that possibly you have to explain, because there is an acceleration because begins at 0, the velocity increases. Then in this portion, the acceleration is positive. In this portion, the acceleration is negative. Then continues negative, and then here, when the velocity is 0 and the acceleration negative, that means that the particle begins to displace to the left. In all this section, goes to the right. Then stops and goes to the left. Once this finish here, this negative part becomes 0 again, 0, and then again to the right, stops, back, to the right and back. So it's some back and forth, right? But goes more to the right than to the left. because this portion is much more than this portion. Okay? So let's stop the share. So what we have to do in the problem, let me just go back here, is sketch the graph. So it's not really a big deal to sketch the graph. But let me just write the equation we have to work with. So is v of t equals e to the 2 sine t minus 1. T equals 0, x equals 0. So that means that it's at the origin. So that's the initial position, correct? Okay, so the graph is no problem. Now B. What happened with B? Let me just share the screen again. Okay, here, okay, now you see the screen. Oh no, this one. Okay, you see the screen? The problem? No, this is not the one. Oops. This one. Okay, this one. Okay, this is the screen now. You see? The second question is, during what interval, right? During what interval you have of time is the particle moving to the left? Give a reason for your answer. This is well. So remember the graph of this thing. Let me just sketch the graph. The graph was more or less something like this, correct? Remember? It's pretty much like that, correct? So we have to find this root. So while the v is positive, this is moving to the right. When the v is negative, this is moving to the left. So we have to determine the intervals where the function is negative, correct? So in this one, again, the velocity is positive, is moving to the right. Here, the velocity is negative, is moving to the left, and so on. So how can we determine this? Is very simple. Oh, let me just, who's here? Okay, we're fine, nobody else. Let me just share screen, the calculator, right? So we have the function, correct? So we have the function, and then we have to discover this root. So from 0 to this point is moving to the right. So that's easy to find. So we put menu, analyze graph, 0, and then just we click and click. So the first 0 is 3.140. Okay, so this is 3.14. Let me see. I think this is pi. Let me just do menu, settings, and let me just put the float to 5 to get more decimals. Now you see, it's exactly pi. So this point is pi, right? Now let's see this one. Menu, analyze graph, 0. We find the 0, 6, 28, 32. So if this is pi, this is 2 pi, correct? Now what do you think is going to be the next one? Leo, what do you think is going to be the next point? If this is pi,
3 pi.
Is pi, this is?
3 pi.
3 pi, that's correct. We can check that. Menu, analyze graph, then 0, click here. Yes, exactly. This is 3 times this one. So 3 pi, so it's pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and so on. So what could be our answer then? So B is, share again screen, the problem. So find during what intervals of time is the particle moving to the left? This is well, it's very simple. So B is from pi to 2 pi. From 3 pi, so from 0 to pi, to pi to 2 pi, to 2 pi to 3 pi, to 3 pi to 4 pi, and so on. So let me just put here, this is the screen. So my question B is, during what interval? So is this one, this is this one, right? And so on, this is pi, 2 pi, 3 pi, 4 pi, and so on. So as you see, it's very important to read the graph. This problem is related with the reading of the graph. Okay? Questions here? Everybody fine? Yep.
Yes.
Okay. Let's go to the next question. Okay, next question is Z. Find the total distance traveled by the particle from T0 to T4. Okay, let's see. So, let me just write that question. Z is total distance from T0, T4. Okay, this question is very important because if you remember how I was describing this one, if this is the 0, the particle is going to move to the right from 0 to 2 pi, from pi, I mean. Then it's going to return a little bit, and then it's going to move again to the right. Then return a little bit, and then return to the right, and so on. So, really, we have to get, for instance, let me just do this, 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 this. So we have to do really all the distance with the back and forth, correct? So this plus this plus this plus this plus this, correct? So it's not the displacement. The total distance is the curve. This is the displacement, correct? So it's different. Remember the last problem we solved? How do you find the total distance?
Absolute value.
Correct. The total distance, right? Distance, yeah, let's just put total distance, right? Is the integral, right, of the absolute value of V of t dt. That's correct. Now, the only situation we have to do is, okay, we have to determine this one. So let me just, this is dx dt equals v of t, correct? This is my formula. So my integration is going to do dx equals v of t dt. Now what is going to happen? I'm going to integrate from 0 to 4, and here from from x at 0 to x at 4, right? And then here from 0 to 4. So the only situation I have to do is the total distance is going to be, the integral from 0 to 4 of the absolute value of Vt dt. Now, x at 0 is 0, so this is not going to be a problem. So we have to evaluate this integral. Well, again, because this is a calculator allowed problem, the only we have to do is here, take the calculator, click on a calculator page, and then take calculus, right? Integral. And then we have to exactly type the integral we had in our paper from 0 through 4, correct? Then absolute value, you have to press here in this menu next to the little book. The absolute value is right here. And then we have to put sign, parentheses, no, that's not sign, is E, exponential 2 times sine x minus 1, no, minus 1 dx, correct? So that's what we have to write in the calculator. So you see, if you remember, it's the same formula. Let me just put the book right here. Let me just go back here, stop share. We screen this one right here. So it's our formula. It's our formula we have here in our paper. except with the absolute value. Okay, now go back again to the calculator. We write the equation, we press enter, oops, right here, enter, and we determine that it's 10.5425, correct? I don't have units, meters or centimeters or miles or something, so these are only length units of the XY coordinate system, correct? Don't forget, your calculator has to be in radians. It's very important. By default, the calculator is in radians, but you have to be careful and try to do this in radians. Because remember, you take it, setup, settings, document settings, you have degrees. Sometimes the less we're going to use degrees, but most of the times we are going to use radians, correct? Okay. Any question here? Okay, let's go back to the assignment right here again. Oh, stop share, right? Let me just go to the problem. This one right here. And let me just go to question V. Is there any time t between 0 and 16 at which the particle returns to the origin? Justify your answer.
Wow.
Yeah, that's correct. But how do you justify the answer?
The negative, the area of the positive, the area of the line above the x-axis is greater than the line below.
Correct. Okay, so we have to go to the graph again. So let me just go to the graph again. Yeah, let's share the graph here. Okay. This is the point, and this is correct. Yeah. To justify this thing, the only you have to do is state that the distance is the integral, is what we did. In our, let me just stop the screen. In our screen, you see the distance is the area. Geometrically, this is the area, correct? The area under the curve. This is area under curve, correct? So this is the distance. So and you see the graph, this area right here is the displacement to the right, represents the displacement to the right. This is the displacement to the left. So this is more than this. So if you add these two, you are at the right of the origin. Then you go more to the right, and then you return this little. So these two are more than these two. So you are still to the right, and so on. So you go back to the left a little bit, but not enough to reach the origin. Very good, random. That's the answer. Okay. Do you have the binder, Brandon?
No,
You have the binder?
Está en robotics.
Ah, great. Okay,
Yeah.
Bueno. Déjenme hacer aquí grabar esto. Okay. So, this is the definition of the acceleration. So, if we need the acceleration in the time 2, we have to take the derivative and evaluate 2. This is the v. So we have to take this derivative in the calculator. So this is what we are going to do right here. So we do menu, calculus, derivative at a point. So this is the variable x, the value. We are going to put a 2, first derivative, okay. And then the only I have to do is put a function. So I'm going to put here negative parentheses t plus 1, t plus 1 times sine. I'm going to put the trigonometry sine, and it's going to be, well, really this has to be an x. This is x squared divided by 2. There it is. So it's quite simple. Enter. Okay, you have this number and you have this strange, so just press Control Enter, and then you get velocity, correct? 1.58758. Okay? So that is the acceleration. Is positive, correct? Now, the situation is this one. The problem, this is part of the problem. You can get 1 point for just answer this portion, but the idea is get the whole point. So let me just go back to the problem. It's a find the acceleration of the particle at time 2. Okay, this is one, possibly they give you 1 point, but the question, this one, is the other point. You have here 4 questions, 9 points. Usually these are 9 points. So possibly this is 2 or 3. Let's see. Is the speed of the particle increasing at t equals 2? Why or why not? It's okay. Let's see. How do you know in physics if something is moving to the right, for instance, right? This is moving to this one, so the velocity is positive. How do you know this? The velocity increase if the acceleration is positive, but the velocity increase. The velocity increase when the acceleration is positive. The velocity, even positive, decrease when the acceleration is negative because it's going in the opposite way. So the acceleration works also in this direction, but in this case, the acceleration works in this one. So this is the point. Now, in the other direction, if your velocity goes in this position, velocity negative, and the acceleration is negative, so the acceleration works in the same one. So the speed increases, correct? The speed increases because now it's negative, right? More negative goes faster to the left, but the speed, the magnitude increases. Now, and when the acceleration is positive, goes in this direction, the speed decreases, correct? So how can you know what situation you have in this problem? Which one? This, or this. So you need to determine the situation when the speed increases to the left or to the right. So you must know that the acceleration and the velocity have the same sign. Negative both or positive both. In this case, let's see. In this case, let me just go back to the screen, right? You found that the acceleration is positive. Now, the speed is going to increase if the velocity is also positive. So what I have to do is very simple. I have to evaluate this in 2. So let me just put this one right here. So I'm going to put negative parentheses 2 plus 1 right here times the sine, trig, sine of parentheses 2 squared divided by 2, right? Now, press enter, and whatever is this, you can do control enter, the number is negative. Now, acceleration positive, velocity negative. Conclusion. The speed is increasing or decreasing? Nobody? So what case we have in this case? We have velocity negative and acceleration positive. So what is going to happen?
Decrease.
Decrease.
Speed.
The speed decreases. So the acceleration is stopping, is opposite to the velocity. The velocity is to the right, but the acceleration goes to the left, correct? It's really this one, yeah? Más bien, has to be, not this one, no es esta, is velocity negative and acceleration positive. Yeah, no, it's that one, exactly. Okay. Pretty much everybody catch the idea? Okay, again. Find the total distance traveled by the particle from time 0 to time 3. Okay, this is pretty much exactly the same question as the problem before. The total distance, so you have to do again the absolute value.
Okay.
Correct? A ver, who has a calculator?
¿Se puede un CX o ocupas un CAS?
Déjame ver. Déjame abrir el CAS. A ver, déjame abrir el CAS. Right. Okay. Bless you.
Gracias.
Okay, let me just share this one. Let me just open this. Déjame cerrar esto. File close. Exit. No. Cancel. Déjame quitar esto, quitar esto. Ok. Déjame usar el CAS. El CAS. Aquí tengo.
Casi. Voy a ir a la oficina para comprarme uno.
A ver, ahí voy. Déjenme compartir now el CAS. No, no es el CAS. ¿Dónde deja? A ver, espérenme tantito. Stop. Bueno, aquí tengo yo una CAS rápida. Chiquita. Una CX. Ok, déjenme poner esta es la CX. Déjenme ver menu, calculus. Ok, tenemos numerical derivative at a point. So, tenemos el mismo menú. So, we can do this with the CAS. And if you press menu, calculus, we have numerical integral. So, tenemos lo mismo, correct? So, it's possible with the CX. You don't need the CAS, correct? So, se puede. So, estas integrales las podemos hacer con el CAS y con el CX. Correct? Esta es una CX.
Sí.
Ok, a ver, entonces, a ver, traten, muchachos. A ver si no se equivocan antes de que yo haga algo.
Pues déjame lo busco entonces.
Ajá. Creo que sería mejor que tuvieran un CAS. Pero es up to you. ¿Sí?
Me dicen cuando Leo va a ir por un calculator y yo voy también.
Ok, ándale pues, Leo, ya sabes.
Sí.
Sí. O se ponen de acuerdo y uno de ustedes viene, se lleva las calculadoras, se las confío. Y ya allá ustedes se ven en Galina y ya se reparten las calculadoras.
No, hombre,
Para
yo
que no den la vuelta a todos.
tengo que manejar 50 minutos, no, hombre.
Organícense.
Está loco.
Okay? Well, let's see. Let me just write the problem right here. So we have to do.
Tiene batería.
So total distance. So is the integral from x0 to x in 4, no, 3, right, of dx equals integral from 0 to 3, absolute value of negative t. Okay. Esta sería the total distance, correct?
Sí.
¿Cuánto les daría?
No sé, no tenía mi calculator.
Okay, bueno. Areli, you have your calculator? Okay. Entonces vamos a ponerle aquí, share screen, this one, calculator, menu, calculus, integral. So from 0 to 3, then absolute value again. So negative, no, it's negative parentheses x plus 1 times sine as x squared divided by 2 dx, correct? So you present it, you get 548.6. Oh, I guess I did something wrong. Let me just put this one right here. I miss a parenthesis right here. I need to put here a parenthesis. That changes everything. Okay, enter. Now, this one, 433382, correct? That is the integral. Now, the situation is this one. This is 43382. Let me just stop the sharing. And now you have that one. So this integral is 433. But what about this part? The situation is this one. X0, yes, this is x of 3 minus x of 0. This is displacement, correct? So what we have to do is play with this one, right? We have to do x of 3 equals x of 0 plus 4.3382. So this is what we have to add. Now, what is this one? X of 0, according with the problem, in 0, the particle is in 1. So it's 1 for 4.3382. Correct? Okay, this is because the particle is already at this position from the origin. Correct? So this is the particle net displacement, right, back and forth. And this is adding the distance from the origin to the initial position. Okay? Okay, let's finish this already. Share the last question. It's right here. It's okay. This is during the time interval 0,3, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. Okay. During the time interval, what is the greatest distance between the particle and the origin? Okay, how can we find this one? Well, possibly is we can pretty much plot this function and check the area, correct? So we can plot this one. Let me just go to the calculator, stop share. So we screen this one, calculator, and then we can open the graph, right? And then this is, well, let me just put here is negative t, negative parentheses, x plus 1 times sine 3 sine x squared divided by 2, correct? And then let's see how is this graph. Oops.
La madre.
Just grab, oh no, grab this one. No. This is time 3. Okay, let me just put here 4, 3. Let me just put this one. Let me just 383. So, no. Okay, here is. Mhm. Okay, let me just define the origin, menu, zoom, Windows zoom, Windows settings, 0, this is fine, 3, let me just put here a 3, press OK. Okay, this is the velocity, correct? At what moment you get the maximum distance?
Pues, ¿dónde está el 3?
Aquí.
Oh, es que no veo. Espérame.
So here is the 3. So how do you read this one? Okay, your velocity is negative, correct? So you're moving to the left. You are in the position 1 that you're moving. Let me just put here F1. Yes. So you have to really, this is from the 1. So you move to the left, to the left, to the left. Then you reach the origin and then you move right, more to the left until this point, correct? At this moment, the velocity, the particle stops. Then the velocity is positive, so from the position it has goes to the left again. So approach to the origin. So what do you think is going to be the time where the distance is at the most?
Porque cuando ya se hace positive, el area of that is smaller than the area of the negative. No, at 3, it's still at a negative position, so it would just be 0.
Okay.
At x equals, or at time equals 0.
Yeah. Let me just put this one here. This diagram finished today, this one. So this is, now, let me just put the axis. Here is the 0, here is the 1, right? And the velocity is something like this. And this is 3, correct? Okay, let me just close this one, stop share. So this is what we have. This is pretty much the sketch of the velocity, correct? So this means that the velocity is negative. Here, the velocity is negative. So the particle begins here. The velocity begins in 0, so it's at rest. So it's more negative, more negative, more negative. That means that accelerates, then reach a max, the velocity right here, and then begins to decelerate until it stops right here, correct? Then at this point, the velocity is positive, so begins to return until pretty much right here. So what time is that? Well, we have to find this intersection. What is this intersection? Okay, what we have to do is go to the calculator right here, and then menu, analyze graph, 0, clean. So let me just menu, settings, float 5. So this is the point, correct? So this is this is 3, this is 2.5066. So let me just stop the thing. So this is what I did. Menu, screen, let me just share. So what I did is this one. I just, from the graph, I just find this 0, and I found that this 0.5066. Then, according with my graph, the moment this is the longest distance in the negative direction to the origin is 2.5066 seconds. Okay. We can stop for today.